we're going to move to the next problem because, again, that one was pretty straightforward. I don't need to really say much about that one other than it is done, okay? That one is done. That was pretty straightforward. If they give you the mole to mole ratio, y'all, you actually can take that as a gift and keep it moving, all right? So if they give you a problem like that, just know that it is a gift because they've already given you the moles. If they don't give you the moles, that's when it becomes a problem. Now, speaking of, let's move to number 2 now. All right. So in number 2, this is what you're working with. You have a chemical reaction that's already balanced. All right. Let me give you a little tip too. If your professor or teacher already balances the equation, then that's a good thing because chances are there are going to be multiple parts to it and they're saving you some of the time, some of the steps so you can get right into the other parts. So for instance, in letter A, it's asking you which limiting reactant if 0.32 moles of aluminum and 0.26 moles are available of oxygen. So they gave you the aluminum value and the oxygen value, right? Well, they want to know, based on those numbers right there, which one is the limiting reactant. So all you have to do, guys, is just pick the smallest number. So again, what was given in the problem? 0.32 moles of aluminum. And they also gave you 0.26 moles of oxygen. Again, this one is easy. Just choose the smallest number of the two. That is your limiting reactant. If they give you this answer in moles, it is that simple. Now, if they give you the question in grams, all right, like in letter C, then you will have more steps to do, all right? But before we get to letter C, let's go ahead and do letter B now, okay? Letter B. Letter B. Now, if you look at letter B, okay, you've got how many moles of aluminum oxide are formed from the reaction of 6.38 times 10 to the negative third moles of oxygen and 9.15 times 10 to the negative third moles of aluminum. Now, I'm going to give you time to look at this particular problem, and I want you to jot it down also, okay? So for those of you all that are watching this on the replay, make sure that you pause the video and watch this also. See if you can do it yourself before you see the solution, okay? So I'm going to give you all time to look at this. Now, I am going to take those numbers there. Let me zoom in so you all can see. I'm going to take those scientific notation moles, right? I'm going to actually rewrite them in decimal form. Just FYI, I'm going to take those numbers that are in scientific notation and I'm going to put them in decimal form, only because it's just going to make things a little simpler in terms of doing the actual problem, okay? So the answer is still going to be the answer, but I just wanted to give you all that heads up on why I'm doing what I'm doing in terms of that, all right? So now I'm going to give you the chance to look at the problem, and let's see what we can do as we solve the problem. Okay, now, something else I wanted to share with you too, okay? I do need to say something about this particular example here. Although we said that the oxygen was the limiting reactant, here is something else that you could also do, because sometimes you may have to change up your problem here, okay? Now, in a case like this, where you're given a balanced equation, the other method that you can do here is you can convert, okay, let me put this here. I'm going to type it, I'm going to write this out. You could also you can also do an additional step, Okay. Of converting. Now, hey, good. Thank you, Cena7. How are you today? See, guys, I always like to show you all more than one way to do these problems because sometimes you'll have to verify your answers here, okay? So, what I recommend that you all do as another alternative, you could take the 4 moles, all right, that's reacting with your oxygen and convert your aluminum to your oxygen moles and vice versa. Sometimes you may end up with a different answer, but this is where doing the extra processes will show that to you, okay? So if your teacher tells you to provide a solution to the problem by backing it up, this is one way. This is an alternative way, but what you also need to do is understand that when you have to show your work, this is what I'm referring to. You could take that 0.32 moles, right, of aluminum. And in this case right here, I could use my coefficients right here in my balanced equation, the 4 and the 3. And what you're going to do in this particular case, you're going to say, all right, well, from the 4 that's in my balanced equation, I'm going to put my 4 moles of aluminum there on the bottom, all right? And on the top, I'm going to put my moles of oxygen right there, which is 3. So if you plug this in, you get 0.32 times 3, and then divide that by 4. Now, in this case right here, you'll end up with 0.24 moles of oxygen. Okay? So if your teacher told you to convert your moles of aluminum to the moles of oxygen, then this is another way that you could do it, all right? So again, in doing an example like this, you end up producing or having as a result 0.24 moles of oxygen if you were to do it this way, all right? Now, let's say that your teacher said, all right, we'll convert the moles of oxygen to aluminum, okay? Let's see what we get in this particular case. Because again, you all may have teachers that may want you to go the extra mile, and they may want you to convert both of them to, each of the reactants. And then this is what you're going to do again. You're going to just use in this particular box right here, the coefficients. Now, you see how originally I put 3 moles of oxygen on the top. Well, this time we're going to put 3 moles of oxygen on the bottom because we want to get rid of them. And I should have demonstrated that up above. So let me go back and make sure you all see that. The moles of oxygen, the moles of aluminum, we cancel those out right there. Okay. Well, same thing here. Moles of oxygen gets canceled out. And on the top, I will put my 4 moles of aluminum. Now, in this case right here, we've got 0.26 times 4 divided by 3, and we get 0.35 moles of aluminum. Now, all right. So as you guys look at these numbers right here, what do you all notice? You're welcome. You are welcome. Yes, hey, Yadi, this is General Chem 1 right now. We're doing limiting reactants, and now we're getting ready to head into theoretical yield. All right. So as you can see here, if you were to convert your answers, all right, you're welcome. If you were to convert, all right, hypothetically, even though we know in this case right here that oxygen is the limiting reactant, take a look right here, okay? If we converted the moles of aluminum to oxygen just to do some extra steps, we still can see here that oxygen is still the limiting reactant. And then suppose you took the oxygen and converted it to aluminum. Again, you still see that your moles of oxygen still has a limiting reactant. For part B now, we're still dealing with the same chemical reaction, all right, which is the aluminum plus your oxygen, which gives you aluminum oxide, okay? Now for part B now, it says how many moles of aluminum are formed from the reaction of 6.38 times 10 to the negative third moles of oxygen and 9.15 times 10 to the negative third moles of aluminum. Now, this is a interesting type of problem. Even though we're dealing with limiting reactants here, you now have additional stuff that you need to do within this example. First thing I'm going to do, because I really don't want to deal with scientific notation, I'm going to take that number, the 6.38 times 10 to the negative third moles. See that? I'm just going to put that in decimal form, okay? That way, I can work with decimals rather than scientific notation. But I want you all to know that you still need to know how to use your calculators for that part, all right? For that part. Now, this is what's given in the problem. They gave you the moles of oxygen and the moles of aluminum, but what they want to know, let me zoom out so we can talk about it. They want to know, okay, what's required are the moles of aluminum oxide. Okay, that's what they want to know. All right. So what you were given, of course, the reaction is already balanced. These are the two things that they were given, but this is what you're looking for, the moles of aluminum oxide. Now, how do we go about doing this? First off, because I know that the number of moles here that is the smallest, okay? The number of moles that is the smallest, is the oxygen right here. That is going to be your limiting reactant. And what you're going to do, you're going to take those moles of oxygen, all right? And you're going to convert them to the moles of aluminum oxide. So this is your limiting reactant right here, okay? That is your limiting reactant. And you're going to take that number of moles and convert it to this number of moles here. Now, you're welcome. You're welcome, Fatima. Now, here's the thing, though. Because I have the moles of oxygen, which is easy. See, we haven't even talked about grams, right? Because we're talking about moles, y'all, I really believe that moles are simpler because you're dealing with the coefficients, and that's it. Unless grams was given, then you would have to do some additional steps. But in this case right here, y'all, look, just take the smallest number first, that's between the two numbers that are given, take the smallest number of moles, and then convert that to the moles of aluminum oxide. So since we already know that 0.00638 moles of oxygen is the limiting reactant, I'm going to convert that to the moles of aluminum oxide because that's what they're asking me to do. On the bottom, I'm going to put moles of oxygen. On the top, I'm going to put moles of aluminum oxide. Again, that's coming from, the coefficients are coming from your oxygen coefficient here of 3 and your coefficient of 2 right there. So on the bottom, I'm going to put 3. On the top, I'm going to put 2. And now you're just going to multiply those two numbers across, all right, and then divide by what is left over, okay? So here we go. We're going to say 0.00638 times 2. Then divide that by 3, and you get 0.00425. And we're going to use just the three numbers, 0.00425 moles of aluminum oxide. And that is our answer right there. Okay? We need it for part C now. I'm going to zoom in so you all can see that. And now this one is going to give you a little tiny headache. Not a migraine, but a headache. Only because we've got the extra math involved, okay? We got extra math. So this is what I'm going to do. Let me zoom back out, and I'm going to write the steps right here beside it. So we're doing 2C, right? 2C, you're going to convert. Okay, these are the steps. Convert 3.17 grams of aluminum to a mole. Convert 2.55 grams of oxygen to a mole. And then choose the smallest mole value as your limiting reactant. Okay? So those are the steps that we're going to go through right now. Again, we're going to convert the 3.17 grams of aluminum to a mole. We're going to convert 2.55 grams of oxygen to a mole. Choose the smallest limiting reactant value. Okay? So I wrote the steps here, but now we're going to actually implement those steps. All right. So let me go ahead and let me also say this too. You do not need, you do not need the balanced equation part for this because you're only doing one step here, all right? So for this first one, I'm going to take the 3.17 grams of aluminum, and I'm going to convert that to a mole. 1 mole of aluminum equals the molar mass. So if you look at your periodic table and find the molar mass for aluminum is 26.98 grams, all right? So if you look at your periodic table, you're going to see that value. Cross out your grams because you don't need that anymore. Get that number. And then you're going to do the same thing for the oxygen. We've got 2.55 grams of oxygen that we're going to convert to a mole of oxygen. Now, we have 2 oxygens. So 2 times 16 gives you the 32.00 grams of oxygen. That's the molar mass for oxygen. Again, you're going to cross out your grams because you don't need that anymore. Okay? So the next thing that you're going to do is calculate those values, okay? So here we go. You've got 3.17 divided by 26.98, and you get 0.117. All right, 0.117 moles of aluminum. We've got 2.55 grams of oxygen divided by 32.00. And here you get 0.0796. So we're just going to round that off to 0.0797. So 0.0797 moles of oxygen. Now, in this case right here, look, the one that provided you with the smallest amount is the limiting reactant. So look at the numbers. This is like saying 11 cents, and this is like saying 7 cents. Obviously, this is the smallest number. All right, y'all. So oxygen is the limiting reactant. All right. Do you use the product side or reactant side? Now, remember, if you hear the word reactant, if they say, let me zoom in so you can see the question. If it says which reactant is limiting, that means you choose the one on the left side. Anything that's on the left side is what you go by. However, whenever it comes to asking you, based on the limiting reactant, how many grams of something that was produced, then in that particular case, that's when you have to use the limiting reactant to then convert it to one of the products. Okay? That's when you go the extra mile, so to speak. Number 3. All right. Look at the problem.